Hey everyone, we're going to look at these 4.8 notes. We're going to do like the first half and then we'll do the rest in class. So we're going to start out by solving the right triangle. If you're going to solve a triangle, you got to find all three angles and all three sides. So I think probably the easiest one at this point is this missing angle. I know that all three angles in a triangle should add up to 180. So if I take 180 and I subtract off the right angle that I have, the 90 degrees, and I'll subtract off the 34.2. All right, and then I'm going to get whatever is left over in angle B. All right, I got a 55.8. All right, angle B is 55.8 degrees. And now I got to find one of the sides. It doesn't really matter which one I start with. Maybe I'll just go with like side A. Sure. That is across from the original angle I got. That's the opposite side. And I do have the adjacent side. So based off of opposite and adjacent, I'm probably going to go with tangent. Tangent of the angle 34.2 degrees equals opposite over adjacent, A over the 19.4. All right, so I'm going to multiply this 19.4 on the other side. And when I put this in my calculator, I'm going to make sure that my mode is in degrees. So I've got 19.4 times tangent of 34.2 degrees. All right, so I got a 13.18 if I round to the nearest hundredth. We'll just read the instructions on the homework and round to whatever they say. So this is side A. All right, and the last thing I have to find is side C, which side C is the hypotenuse. And because I rounded the side A, I'd rather use one that I didn't round. I think I'm going to go with the side B here. It's still messy decimal, but it was not rounded. So if I go with the adjacent and the hypotenuse, I probably want the hypotenuse over the adjacent. So I'm probably going to go with secant of my angle. And I'm still sticking with this angle 34.2 degrees. And my hypotenuse is a C. The adjacent is the 19.4. So I will multiply by 19.4 over the other side and solve for C. Again, I'm going to check my mode, make sure my mode is in degrees. And I don't really have a secant button on my calculator. So I'm going to have to enter this in my calculator as 19.4 times 1 over cosine. Secant is the reciprocal. So I'm really going to put it like this, 19.4 times 1 over cosine of my 34.2 degrees. All right, this is going to give me the C here. All right, I got a 23.46 if I round to the nearest hundredth. All right. So we now have all three angles and all three sides. So we have solved the triangle. All right, so let's look at one of the word problems. For number 2 here, the height of a mountain is 5,000 feet. The distance between its peak and that of an adjacent mountain is 25,000 feet. The angle of elevation between the two peaks is 27 degrees. So what's the height of the adjacent mountain? Let's talk about the vocabulary they used here real quick. This is an angle of elevation. Angle of elevation means you have to go from a horizontal line and up. This would be an angle of elevation. And then the exact opposite of that is going to be an angle of depression. It has to go from a horizontal line and then it has to go down from there. So this would be an angle of depression. Okay, but it's about comparing it to a horizontal line. So notice that that's why they've got this horizontal line right here, that's side B. All right, so they said the angle of elevation from that horizontal line up was 27 degrees. So we're trying to find the height of the adjacent mountain. So how tall this is, let's get this A first. That A is opposite from my 27 degrees. And I don't know anything about the adjacent, the side B. I do know the hypotenuse. So out of all my 6 trig functions, to do the opposite over hypotenuse, I'm probably going to go with sine. Sine of 27 degrees is the opposite, in our case A, over the hypotenuse, 25,000. All right, so I will multiply that 25,000 over the other side. And I can put this in my calculator. Again, I'm going to make sure I've got my mode in degrees. So 25,000 times sine of 27 degrees gives me, all right, so 11,349.76 if I round to the nearest hundredth. All right, now that was this opposite side. That was not exactly the entire height of the mountain. So I got to consider this 5,000 feet at the bottom here. I'm going to do 5,000 and then add on to this side A that we just found. Okay. So it looks like I got up to 16,349.76. And I think our units were in feet here. So that would be how tall the the taller mountain is. I mean, if I stopped at this right here, I didn't get the entire height of the mountain. So make sure you add up both of those. Okay, so we were going for this whole height. There we go. And then number 3 here, very similar. They've got an angle of elevation again. So that goes from the horizontal line and then it's angle up from the horizontal line. It says at a point 200 feet from the base of a building, so here's my 200 feet there, away from the base, the angle of elevation to the bottom of the smokestack. So here's my smokestack right here, and we're going to the bottom of it. All right, so that angle of elevation was 35 degrees. So you can see this labeled right here, 35 degrees to get up to the bottom of it. Now, it's an angle of elevation of 53 degrees if you're going up to the top of this. So this is the larger angle of 53 degrees. All right, so they've shown it all in our little picture here. And they want us to find the height of the smokestack alone. So not like this whole distance, including the building and everything. They just want the height of this smokestack. So I think I'm gonna have to get 2 different numbers here. I'm gonna get the overall height, and then I'll subtract off this bottom height, and then whatever is left will be the height of the smokestack. All right, so let's deal with this overall big triangle right here. I'm gonna get this height all the way to the top. And that was an angle of elevation of 53 degrees. Across from the 53 degrees, this would be my opposite side over here. And then I know the 200 feet. I don't really know anything about the hypotenuse, so I'm not really going to use it. I do know this adjacent side, though, is 200 feet. So using the opposite and adjacent, I'll probably go with tangent. Tangent of my 53 degrees equals opposite, let's call it x, the unknown side here, over the adjacent, which I know is 200 feet. So I'm going to multiply that 200 on both sides. All right, and again, I'm going to do 200 times the tangent of 53 degrees. My mode on my calculator is in degrees, so I'm at 265.41 if I round to the nearest hundredth. So that's that x distance, that overall big distance there. But I just want the distance of the smokestack, so I need to subtract off this bottom distance down here. So I'm going to use this triangle at the bottom here, which had an angle of elevation of 35 degrees. All right, so the opposite side, I'm gonna put another X here. I'm gonna get that opposite side compared to the adjacent side is still 200 feet. That hasn't changed. So I'm still doing opposite, I'm still doing adjacent, I'm still gonna have to do tangent of that's the angle that's different this time. This is a smaller angle of 35 degrees. All right, equals the opposite over adjacent. I'm gonna multiply that 200 over to the other side. And 200 times tangent of 35 degrees is giving me 140.04 if I go to the nearest hundredth. All right, so that's like my smaller distance there. They just want the distance of this smokestack though. So if I want just this distance, I will do the overall distance, the 265.41, minus the smaller distance, the 140.04. All right. It looks like I'm at 125.37. And I think they were doing anything in terms of feet. So that is 125.37 feet tall, the smokestack alone. All right. And one more, this one's about a swimming pool. So a swimming pool is 20 meters long and 12 meters wide. The bottom of the pool is slanted, so the water depth is 1.3 meters at the shallow end, and then it's 4 meters at the deep end. So find the angle of depression, which it kind of highlights for you right here, the angle of depression in degrees of the bottom of the pool. So they kind of laid this out for us all nice. Notice that they didn't use your 12 meters wide. Pretty much this would have to be like a three-dimensional like pool here. You got the 20, and this would have to be 12 wide. So they didn't really draw that whole thing. They were just drawing us this triangle that we needed to answer their question. The angle of depression. Again, an angle of depression goes from a horizontal line, and then it goes down from there. So that's why this is my angle of depression. All right, they want that in degrees. And as far as all the information here, I'm gonna look at just this triangle. And on this triangle, I've got the opposite of the angle we're talking about is the 2.7. And then the adjacent to the angle was 20. So maybe I'll just draw this again here. Here's my angle that I'm going for. And the opposite side here was the 2.7. I am not really using the 1.3. That's kind of above this triangle. And the adjacent was my 20 meters. The hypotenuse here, I actually don't have any information about the hypotenuse, so I'm not really going to use it. I'm trying to find this angle of depression. So let's see, I'm going to do opposite over adjacent, which is tangent. So the tangent of this angle equals the opposite 2.7 over the adjacent 20. All right, so the thing that's a little different here is I don't know what the angle is. So I can do my 2.7 divided by 20, and I can get this down to 0.135. And if it was something that I can recognize from the unit circle, great, I would go with that. But this messy decimal I'm not familiar with. I'm going to find that angle by doing a tangent inverse. Inverse functions kind of swap your input and output. I'm now going to put in the 0.135, and I'm going to get out my angle theta. All right, now again, my mode is in degrees on my calculator. So I'm going to do my tangent inverse of 0.135, and I ended up with 7.69, and we're in degrees here, so 7.69 degrees. That's the angle of depression. All right.